In this video, we learn how to do an hypothesis test for a quantitative variable according to a qualitative variable. We are in this part of the table. If we read the first exercise, it says that we have to compare the cholesterol of women and men at the beginning of the study. Cholesterol is a quantitative variable and sex qualitative variable. Second, our samples are independent. The observations of the first sample are related with the observations of the second sample. Once we know which kind of samples are, then we have to prove if our variables follows a normal distribution or not. We go to SPSS, then we go to Analyze, in Descriptive Statistics, and Explore. In dependent list, we have to select our quantitative variable, in that case cholesterol 0, because we have to compare the cholesterol level at the beginning of the study. And in the factor list, we have to select our qualitative variable sex. In order to select the normality test, we have to go in plots and then select normality plots with tests. Finally, we have to click on continue and OK. Then our results window is open. First, we can see a complete descriptive statistics. The last table is referred to normality test. In this example, the most suitable test for normality is the Kolmogorov-Smirnov, because our samples are larger than 50 observations. We get a p-value equal to 0.2. Then we have enough evidences to don't reject the null hypothesis. We can assume that our variables follow a normal distribution. Once we know that our variables follow the normal distribution, we have to prove if the variances are equal or not. SPSS do at the same time the test for equality of variances and the test for equality of means. Then, in order to do both tests, we go to SPSS and then in Analyze, Compare Means and Independent Samples t-test. In test variables, we have to put our quantitative variable, in that case cholesterol 0. Group variable, we have to put our qualitative variable, in that case sex. Now we have to define our groups. In that case, sex is defining as 1 and 0. Then we in define groups here, in group 1 we have to put 0. And in group 2 we have to put 1 and then continue. And finally we can click on OK. Now the results window is open. We can observe a table is called t-test. The first part of the table is dedicated to equality variances test. In that case, we get a p-value equal to 0.173. Then we have enough evidences to don't reject the null hypothesis. Then we can assume that the variances are equal. The second part of the table is dedicated to t-test for equality of means. In that case, the variances are equal. Therefore, our results are in the first row of the table. We get a p-value smaller than 0.05 or alpha. Then we have enough evidences to reject the null hypothesis. This table also shows the mean of the differences and its confidence interval. In that example, we use the student t-test in order to compare the means because our quantitative variable in both categories of the qualitative variables follow a normal distribution. Unless we have enough evidences to assume normality, then we have to use non-parametric test. In that case, man-Whitney, because our samples are independent. Then we go to SPSS and analyze non-parametric test, independent samples. Sorry, it's not here, sorry. Cancel, analyze, non-parametric test, legacy dialogues, two independent samples. In test variable list, we have to put our quantitative variable, cholesterol 0, and in grouping variable, we have to put our qualitative variable, sex. Now we have to define our groups as we did before, 0 and 1, because we define our groups like that. Continue, and finally we have to select our test type. In that case, the most suitable test is man-Whitney U, and finally OK. In the results window, we can observe a table called man-Whitney test. And then we can observe that we get a p-value, this is the p-value, smaller than 0.05 or alpha. Therefore, we have enough evidences to reject the null hypothesis. Then the cholesterol level of men is different to cholesterol level of women.